Every day, we face thousands of different choices, from major milestones to more trivial questions. But even our smallest decisions might make a huge impact down the line. So if we set a goal right now for who we want to be in the future, the probability that we'll get there just from making random, uninformed decisions at every turn is very small. So in that case, how do we arrive at where we need to be? Turns out, we're not the only ones with this problem. Within the human body, every protein is built from amino acids, and these amino acids are joined together by peptide bonds. A chain of amino acids is known as a polypeptide, and these polypeptides will become proteins that carry out a diverse set of functions, from shuttling oxygen around the human body to protecting us against viruses and bacteria. But before a polypeptide chain graduates into a functional protein, it needs to fold into the correct shape. And that's where we see a problem. If a polypeptide chain is 100 amino acids long and each amino acid can adopt 3 possible configurations, then the total number of possible 3D structures for that protein would be 3 raised to the power of 100, or 5.15 times 10 to the power of 47. Let's say our protein randomly samples each possible configuration, trying them on one by one until it reaches the correct structure. Even if our polypeptide is able to try 10 trillion possibilities every second, it would take 1.6 times 10 to the power of 18 billion years to try them all, longer than the age of the universe. And this is known as the Levinthal's paradox. In reality, though, we know that proteins spontaneously fold themselves in less than a second. But how? One possibility points to evolution. Natural selection might have favored the proteins that can fall quickly and accurately into their functional shape. Because of this, a folded protein must have a lower energy than an unfolded one. Picture an entirely flat golf course, where a hole-in-one represents a correctly folded protein. If a polypeptide is randomly sampling possible configurations, it's like we're dropping the ball from above with our eyes closed. In that case, the chance of being correct in just a couple of tries is very small. But remember, a folded protein has a lower energy state than an unfolded one, so our golf course is actually shaped like a funnel. And if you look at it from a 3-dimensional perspective, it has a greater number of high energy configurations than low energy configurations. So the golf ball, or in this case, our protein, gradually arrives at more and more thermodynamically favorable states, and we get a hole-in-one almost every time. Of course, this energy funnel isn't perfect. In reality, it has some hills and valleys along the way and is known as an energy landscape. Even though a protein starts out at the highest energy level, it might transition past intermediate states as it begins to fold, before finally reaching the lowest energy state as a functional protein. So just as protein folding is biased, our day-to-day choices are definitely not random. Sure, we might see some bumps and bruises in our personal landscapes from time to time, but if a polypeptide chain with trillions of possible final destinations can miraculously get where it needs to be, then maybe we can too.